All right. Let me have a question. Yeah, it's a video. Yes. Hello. All right.
Claire, we're done without you.
All right. Karina has a question. It is. Okay. Yeah, it's 6.5, yes. Okay. Raising an exponent to an exponent. All right. So how about x squared to the third power? You're multiplying, right? Because remember what that means. X squared times itself 3 times, and you're back to this third rule right here. So that's x to the 6th. It's real quick if you can remember. We're going to multiply the exponents. Keep the base. Okay? Now there's no base to disappear, but yes, no.
So if being x to the negative 6, or if you had like x to the negative 2nd times the weight to the third power, it would be x to the negative 6, which would be 1 over x to the 6th.
Correct. It's x to the negative 6, which is 1 over x to the 6th. Yep. All right, raising a group to an exponent. So usually you have a group as in a number. Let's make it a little bit more complex than that. Let's do 2xy to the 2nd to the 3rd. Okay? Every member of the group gets raised to the power. Okay? So we have 2 to the 3rd. We have x to the 3rd. We have y squared to the 3rd. Okay? What's 2 to the 3rd? We usually don't leave that as 2 to the 3rd. We write that as 8. X to the 3rd is done. Y squared to the 3rd is y to the 6th. Okay? If we had an exponent in there, let's say negative 2x to the negative exponent, negative 1y squared to the 2nd. We have negative 2x to the minus 1y squared, the whole thing. We're doing negative 2 to the 2nd. We're doing x to the minus 1 to the 2nd. We're doing y squared to the 2nd. Okay, the parentheses make a huge difference. Negative 2 to the 2nd is what? Positive 4. You get a negative 2 times itself. A negative times a negative is a positive. X to the negative 1 to the 2nd is x to the minus 2, right? And y to the 2nd is y to the 4th. Okay? The negative piece moves down, leave the 4, leave the y, and x to the negative 2 moves down as x to the 2nd. I'm done with it. Okay? So the negative exponents usually we take care of. Anybody have any questions? All right. Okay, so that's all review. You should have done a little bit of Algebra 1 exponents. Christina, are you in Algebra 1 now? Or yes, you think so? That's scary. I'm sure probably in Algebra 1 we probably haven't done any exponents yet, other than like 2 to the some power. Probably haven't done much with the variable exponents because that's kind of after polynomials. But you certainly did a lot of it. You all certainly did a lot of it now too, right? Yeah, you had a whole section on it. Okay. We don't go crazy, but there are some things that you're like, okay, you do have to remember the rules. All right, so let's talk about an exponential function because remember this chapter is about exponential and logarithm functions. All right, so the exponential function looks like this. F of x equals c a to the x. All right, a is a positive real number, okay, which means a is greater than 0. Okay, so we're not raising negative numbers to a power for an exponential function. All right, A is not 1. If A is 1, what do you know about 1 to any power? It's 1. So it would be like, wow, that's really exciting. A is 1. That's just 1. Okay? So that's why they eliminate that, because it's just kind of a moot point. All right? C is not 0, because again, if C is 0, that makes that function 0. That is a constant. It's not an exponential. Yes, Melanie?
So if we want to make a side note, can we say that A is always greater than 1?
No, because then you're missing
So
one
it
half.
can be a fraction.
Yes, that can be a fraction. Okay. Is a real C is a real number. Now, reals, remember, are radicals, but they're not imaginary. Real, imaginary. Those are your opposites. Okay, the domain of F is the set of all real numbers. Let's talk about that. Domain are your x values. Exponents can be negative. We just had some. Can be fractions. Where would the fractions come from? Where would, what is that really? X to the 1/2. That's right, Maria. You're so smart. Okay, remember that's a power on the top. So that's the first power, and the roots on the bottom. So that's square root that we assume when we write square root. So that's where the halves come from, and the 3/2 and 3/4 and all that. So it can be fractions, can be negatives, can be anything real. Okay, the base A is the growth factor. We'll talk about that in a little bit. A is what it's growing by, and because f of 0 is C, we call C the initial value, and you all have that from it. Say the word, right? Okay, so give me some examples. I'll start. Let's say 2 times 3 to the x. That's an example of an exponential function. Okay? That is not 6 to the x power, girls. Be careful. That 2 is separate. The 3 is the only thing going to the x power. Okay? Somebody give me another one of an example of an exponential function. Example, Lauren. Okay, very good. Where your growth factor's 2 here, your growth factor's 3 here, to there. All right. What about this one? Does this fit all the criteria? Yes? What's C? Negative 1. C is negative 1. What's A? 2. Okay? This really is this. Because remember, we're not taking, this is not this. It's not the same thing. Okay? This is the opposite of 2 to the x, and this is negative 2 to the x power. Yes, Carol? You didn't really multiply it, just was kind of that one assumed. That's a good question, though. It's not really multiplied, it's just we don't have to write the negative 1 when we multiply it. Very good question, though. So those are your examples. Basically, remember, just side notes here. X is the power on an exponential function. Okay? That's how you differentiate. This y equals 4x cubed. Oops. Is this an exponential function? No. What is it? What kind is it? It's a cubic, which is categorized in which general, broader thing. Polynomial, nice. Okay? Okay? So you have an x as a base, it's not an exponential function, and x as the power creates the exponential function. Okay? Now, we're moving into, I'm sure you've noticed, but Precal is using a lot of words that you probably are like, yeah, I'm good on words, because calculus is huge on theory and words. So That's why we gotta know words. I had a transfer student from, I won't say the public school, but she was very smart, nothing, there. But she taught herself, because her teachers just gave out worksheets and said, okay, do these. And so they worked together and taught themselves, and they didn't know the language. And so when I said back to her, she was like, what do you mean? Well, remember, you're gonna put in parentheses. Oh, okay. But she didn't know any of the language. So you gotta know the language in order to proceed here. Okay. So we've got two functions here. It says they're either linear, exponential, or neither. Okay. For those that are linear, we're going to find the linear function. For those that are that is exponential, we're going to find the exponential function. Okay. So let's talk about a linear function. What does that look like, first of all? What's your basic general form that usually you associate with linear function? Good job, Sarah. All right. And, of course, now the exponential function is, what again? Y equals CA to the X. Good. Okay. So that's what we have to figure out. I hid the hints, so you maybe would think about this a little bit than me just like telling you what to do. But any suggestions of what we could do? We did this, certainly not exponentially, but you did it with linears back in the day, in Algebra 1 day. You had to figure out if it was a linear function or not. You had to figure out if it was a direct variation. That was the easiest time. So what do you want to do? Yes, yes. So you're going to kind of be looking at a slope, and that's my hint. Good job, Lauren. My hint is, this is what you want to look at. Look at the ratio of consecutive outputs, which is basically what she said, looking at the y's. Because if it's a linear function, what do you know about the ratio of your consecutive outputs? They're all going to be the same, right? Okay, so let's see. These are all consecutive because we go from -1 to 0 to 1 to 2 to 3. That's a consecutive input. So these are consecutive outputs. What's the difference in 5 and 2? The difference in this is, depending on which direction you're going. We're going down, so we'll do this. Okay, what about this? 3 again. Hit 3 again. And 3 again. These are all -1. So it looks like this is probably what? Linear, where the slope is what? -3. Yes. If you want to, if you're like, wait, where'd she get that? She took any of these things. She said 5. This is y2 minus y1. 5 minus 2. I'm just going to take 2 consecutive ones. I can take any, but they're right here. Since we've already done that, that's 3. Over the consecutive -1 minus 0. There's your -1. That's just the old slope formula. Is what we're doing just in a table thing. Okay. So if this is linear, how do I figure out the rest of it? Y equals mx plus b. I got my m, but I need my b. How do I do that without graphing? I don't want to graph. Kara? Nice. Looky there, how smart Kara is. There's your y-intercept. How many of you all saw that? Did you see that? Connie, good job. Good job. Now, if we didn't see it, -3x plus 2. There's my function right here. Okay? You all know what to do if you didn't have the 0 contained in here, right? Plug in a random x and y right here. And then anything missing would be the b and b, yada yada. Okay, so we're going to do the same thing. We're going to look at the ratio of consecutive outputs over on that chart. Yeah, you can guess. I bet $10 is an exponential. Okay, but let's see what happens. All right, this is negative 1, negative 1, negative 1, if we're going to go down, just because it's convenient. All right, what's the difference between this x outputs? 16, and then not 16, then still not 16. Okay. Now, what would be nice is if you can see from here what the growth factor is. Y'all see it? It's 2, because these are all powers of 2. This is 2 to the 4th. This is 2 to the 3rd. This is 2 squared, and this is 2 to the 1st power. Okay? So that makes C exponential. A, growth factor. We're growing by a power of 2. Melanie, do you have a question?
Why is it that you live on that side is being divided by that side is being 16? Because technically it's going up on
This was I'm still subtracting this minus this, and I'm subtracting this minus this. I did the same thing over here. These were all negative ones. I just didn't go. And then if I subtract 16 minus 8, it's a positive 8. Okay, so let's see. Y equals C. A is a 2 to the x. Okay. We've never done this before, I don't think. So what could I do to find my C? I know my A. C, A to the x. That's what I'm looking for now. I know my A from what number showed up here. What do you think, Lauren? Okay. Any suggestions? Which one would you like?
I have a question. Could you not put the 0, or the one that's 0, 16 in? Are you good?
Yeah, this is your initial value, remember?
Okay.
So that is that one. So if you recognize that's your Y, I'm done with it. Now, if you didn't, it's just like right here. If you didn't, like, oh wait, I'm totally missed that, then you're plugging in an X and a Y, and you're going to find it that way anyway. So if we, like, not real sure about that, this is the first time I'm doing that, let's try it. Let's plug in 0 and 16. 16 goes in for 0, for Y, sorry. C, 2 to the 0 power. What's anything to the 0 power? 1. 1 times C. C is clearly 16. Okay? Yes, go ahead.
So C is just put X together.
Yes, C is the initial value. Yes. And X is the 0 power. Just reiterate where that is over here. We call C the initial value because that's when X equals 0. Okay? All right, so that's how you tell the difference between linear and exponential. Any other questions? Good work. All right, let's see what these graphs look like. 2 to the x. Again, not very experienced with graphing exponential, so let's start out with our handy-dandy table. We love those, don't we? When we started, Christina, you been to doing full intercept yet? Yeah, so she's already passed the plug in the freaking table. It's so boring. Okay, so 2 to the 0, 2 to the first, and 2 to the minus 1. It should give us enough once we know the shape of it. What's 2 to the 0, Lydia? 1. What's 2 to the 1? Sorry, that's embarrassing. 2 to the minus 1, Alexa, what's that?
The minus 1?
Yeah. Which is otherwise known as 1/2, right? Okay. So let's see if this is enough to graph. 2 to the x, 0, 1, right here. 1, 2. don't draw a line here. It's not a linear function. -1 to the 1/2 right here. Okay, is that enough? Probably not if you didn't know what it looked like. So let's put in a 2, and let's put in a -2 and see if that's enough. All right, if I plug in a 2, what's that? 2 squared equals 4. So 1, 2, here's 2, here's 4. Okay. What happens when I put in a 2 to the -2? What's that? 1/4. So here's -2. We're going to go right here. All right. Don't know what it looks like yet. What does it look like?
Looks like an exponential.
Okay. That's what it looks like. An exponential function looks like this. Okay. Welcome to the exponential function world. That's what they look like. Okay. That's, there's 2 different kinds. But honestly, I would put this one right up there with the linear function, the eventually log function, quadratic. You should be able to pull it up pretty quickly. And now that you know what they look like, these 3 points should be good enough to give you a graph pretty quickly. Okay? Are we seriously going to be done in 5 minutes here? Good Lord. What happened to our time? Yes, Karen?
Is it never going to cross the X?
Or no, it is not. And that's an excellent question. Was that what you were going to ask too? Somebody else?
Yeah.
Okay. How would it cross? That means this would have to equal 0. 2 to the x equals 0.
Oh, but that.
That's never going to happen. Is 2 to the x even ever going to be negative? No. 2 to any power. Think about it. Even if we throw negative numbers in there, all we're getting is fractions when we throw negative numbers. So we're not going to be, this is never going to happen in either of these cases. So what would you call this? That's right. Y equals 0 would be a horizontal asymptote. Okay, and that's my next slide probably, except I probably, yes. Okay. I need to let's just say, all right, let's read through this and then we'll look at our homework again. The domain is a set of all real numbers. Remember, x can be anything, okay? The range is a set of positive real numbers. I do believe that Kara and whoever else is going to talk about that just said that differently. It's never going to be negative, so that your range is from y equals 0 on up, okay? There are no x-intercepts, just said that. The y-intercept is 1. Duh, there's your y-intercept, okay? F of x equals a is an increasing function. It's always increasing as we go left to right, which is how we read the graph. Our y is getting bigger and bigger and bigger and bigger. That's an increasing function. The graph of f contains the points la la la. It's smooth and continuous with no corners or gaps. Now, should you memorize that information? No. That's just way too random. It makes sense when you're looking at the graph. Should you know how to graph an exponential function? Yes. Okay. So let's read that.